Now, in this lecture, we'll find out the radius of the biggest circle. In the drawing, we have 4 circles. 3 circles are located inside the biggest circle, and we want to find out the area of the biggest circle. So, first of all, I will explain to you two terms. When two circles are tangent to each other, there is two types of tangency. The first type of tangency is when they are touching each other internally, and it is defined as internal lunge. Those two circles are touching each other at point S. S is the point of tangency between those two circles, and we know here that the center of the small circle is at point M, the center of the big circle is at point O, the radius of the big circle is equal to capital R, the radius of the small circle is equal to small r, and the distance between their centers, that is equal to MO, or OM, is equal to the difference between the lengths of their radiuses. That is to say, OM equals to capital R minus small r. And here you can see, it is very easy to see that OS equals to capital R, SM equals to small r, and OM equals to OS, that is capital R, minus SM, that is small r, that is to say OM equals to capital R minus small r. Okay? So, this is the first type of tangency, and the second type of tangency between two circles is the external lunge. When two circles are touching each other externally, like in this drawing, those two circles touching each other at point S. Point S is the point of tangency, and they are tangent to each other at point S, or they are touching each other at point S. This type of tangency is defined as external lunge, and the distance OM between their centers, you can see it easily, that the distance OM equals to capital R plus small r. So when two circles are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of their radiuses. In this case, it's capital R plus small r. Okay? Now we'll solve the question. We want to find out the radius of the biggest circle. So first of all, we will define, we know actually here that the radius of this circle is equal to 4 units, the radius of this circle is equal to 9 units, and the radius of this, the smallest circle, is equal to 1 unit, and we want to find out the radius of the biggest circle. So here we will define the center of this circle as point A. We will define the center of this circle as point B. we will define the center of the smallest circle as point C, and we will define the center of the biggest circle as point O, and we will also define the radius of the biggest circle as capital R. Okay, so I write it down. Capital R is the radius of the biggest circle. In the drawing we have also this straight line. This straight line is tangent to the three circles. The point of tendency between the straight line and this circle is at this point. So we define the point of tendency as point D. The point of tendency of this circle with the straight line is at this point. We define the point of tendency here as point E, and we define the point of tendency of the smallest circle with the straight line as point F. We will join together points A and D by a straight line. Actually, AD is defined as the radius of this circle because of the fact that it starts from the center of the circle and ends at point D, that is the point of the circle itself. Therefore, AD is the radius of this circle. That is to say, it equals to 4 units. And we will join points B and D together by a straight line. Here, BE is also the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point B, and ends at point E, that is a point on this circle itself. Therefore, BE is the radius of this circle, that is to say it equals to 9 units. So write it down, BE equals to 9 units. We will join points C and F together by a straight line. And CF is the radius of the smallest circle for the same reason, because it starts from point C, that is the center of the smallest circle, and ends at point F, that is a point on the smallest circle itself. Therefore, CF is the radius of this circle, that is to say it equals to 1 unit. So I write it here that CF equals to 1 unit. In the next step, I will present to you a new rule. This is actually rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius. Drawn to its point of tangency. I read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So here actually we have the radius AD of this circle. It is drawn to the point of tangency, that is to say, it is drawn to point D, that is the point of tangency of the straight line with this circle. Therefore, the straight line that is the tangent will be perpendicular to this radius, the radius AD. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we have the radius BE is drawn to the point of tangency, that is to say, it is drawn to point E, that is the point of tangency of this tangent with the circle. Therefore, the radius BE will be perpendicular to the tangent, or the tangent will be perpendicular to the radius BE. The tangent will be perpendicular to the radius BE. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, the radius CF is drawn to the point of tangency, that is to say, it is drawn to point F, that is the point of tangency of this tangent with the smallest circle. Therefore, the tangent will be perpendicular to the radius CF, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? So, here, in the next step, we will, from point A, we will draw perpendicular to BE. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. We will define the touching point between the perpendicular from point A and BE as point P. We will focus on quadrilateral APDE. In quadrilateral APDE, in this quadrilateral APDE, we have three right angles, 1, 2, 3. The sum of three right angles is 90 times 3 is 270 degrees, plus the size of angle DAP, this angle, in total the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we will subtract 270 degrees from this equation, and we will get that angle DAP, the missing angle, equals to 360 degrees minus 270 degrees is 90 degrees. So angle DAP is a right angle, it equals to 90 degrees. So here, angle DAP equals to 90 degrees. Because of the fact that angle DAP, this angle equals to 90 degrees, we will conclude, and quadrilateral DAPE is four right angles, therefore quadrilateral DAPE is a rectangle. Quadrilateral APDE or DEPE, it is the same. APDE is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, AD is equal to PE. AD equals to PE. Again, AD equals to PE, according to the rule that the opposite sides of a rectangle are equal to each other. But AD equals to 4 units. It is the radius of this circle. From this equation, 4 equals to AD equals to PE, we will conclude that PE also equals to 4 units. PE also equal to 4 units. BE equals to 9 units. BE equals to 9 units, BP equals to 4 units, BE equals to 9 units, EP equals to 4 units, therefore BP equals to BE minus EP, I write it down. BP, this line segment, equals to BE minus EP. Again, BP equals to BE minus EP, that is to say, BP equals to BE, that is 9 units, minus EP, that is 4 units. 9 minus 4 is 5, so BP equals to 5 units. You can write down here that BP equals to 5 units. In the next step, from point O, we will draw perpendicular to DE. So this angle equals to 90 degrees, and this angle also equals to 90 degrees, and we will define the touching point between the perpendicular from point O to DE as point M. We will define the intersection point between MO and AP as point S. And here quadrilateral ASDM has three right angles. Quadrilateral ASDM has three right angles, 1, 2, 3. And the sum of the angles in any quadrilateral is equal to 360 degrees. So the sum of three angles is 90 times 3 is 270 degrees, plus the size of this angle, it is actually angle ASM. In total, the sum of those four angles must be equal to 360 degrees. (270 plus angle ASM, this angle ASM, write it down again, 270 degrees plus angle ASM must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we will subtract 270 degrees from this equation and we get that angle ASM equals to 360 degrees minus 270 degrees is 90 degrees. So this angle is a right angle, it equals to 90 degrees. And here we draw perpendicular from point O to OM. So OM as a perpendicular is a straight line. I write it down. OM is a straight line. OM is a straight line. Again, OM is a straight line. And we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So here, if we focus on this side of the straight line OM at point S, then the sum of the angles must be equal to 180 degrees. So which angles we have at point S? We have here 90 degrees plus angle OSA. In total, the sum of those two angles must be equal to 180 degrees. According to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Here we will subtract 90 degrees from this equation and we will get that angle OSA equals to 180 degrees minus 90 degrees is 90 degrees. So here angle OSA is a right angle equal to 90 degrees. Likewise, quadrilateral SMEP has 3 right angles, 1, 2, 3. I'll write it down. Quadrilateral SMEP has 3 right angles, and the sum of 3 right angles is 270 degrees, plus the size of angle MSP, this angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we'll subtract 270 degrees from this equation, and we'll get that angle MSP is equal to 360 degrees minus 270 degrees is 90 degrees. So this angle is a right angle, it equals to 90 degrees. Therefore, quadrilateral SPME has 4 right angles, and any quadrilateral that has 4 right angles, it is a rectangle. So actually, quadrilateral SPEM is a rectangle. This quadrilateral is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, SM equals to EP, SM equals to EP. The opposite sides of a rectangle are equal to each other. That is to say, SM equals to EP. But EP equals to 4 units. We've already found out that EP equals to 4 units. So from this equation, SM equals to EP equals to 4, we will conclude that SM also equals to 4. SM equals to 4. So we can write here that SM equals to 4. In the next step, we will join points A and B together by a straight line. What is the length of AB? What is the length of AB? The length of AB, actually A is the center of this circle that is radius is 4 units. B is the center of this circle that is its radius is 9 units. Those two circles have an external lunge between them, that is to say they are touching each other at this point externally. Therefore, the distance between their centers, that is to say AB, will be equal to the sum of the lengths of their radiuses. That is to say, it will be equal to 4 plus 9, because the radius of this circle is 4 units, the radius of this circle is 9 units. Therefore, the sum of the lengths of the radiuses is 4 plus 9. 4 plus 9 is 13. So we found out that AB equals to 4 plus 9, that is 13. We have already found out that BP equals to 5 units. So we will focus on the right triangle, triangle ABP. On the right triangle, triangle ABP, according to the Pythagoras theorem, here PT is abbreviation for Pythagoras theorem. So according to the Pythagoras theorem, in the right triangle, triangle ABP, this right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB, so the square of the hypotenuse is AB squared. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB squared equals to BP squared plus AP squared. I'll repeat again. In the right triangle, triangle ABP, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB squared, that is the square of the hypotenuse, equals to the sum of the squares of the perpendiculars, equals to BP squared plus AP squared. Here, AB, we already found out that AB equals to 13 units. AB squared is 13 squared. 13 squared is 169. Equals to BP squared. BP, here BP equals to 5 units, so BP squared is 5 squared. 5 squared is 25 plus AP squared. So in conclusion, we found out that 169 equals to 25 plus AP squared. Here we'll subtract 25 from this equation and we'll get that 169 minus 25 is 144. So 144 equals to AP squared. Here we'll take a root out of this equation and we'll get that AP equals to the square root of 144. The square root of 144 is 12. So we found out that AP equals to 12 units. Here we can write down that AP equals to 12 units. We have already proved that quadrangle APDE is a rectangle. So in rectangle APDE, we know that the opposite sides are equal to each other. That is to say, AP equals to DE. In rectangle APDE, the opposite sides are equal to each other. That is to say, AP equals to DE. But we just right now found out that AP equals to 12. So from this equation, 12 equals to AP equals to DE, we will conclude that DE also equals to 12 units. So we can write here that DE equals to 12 units. In the next step, we will define ME as X. Again, ME equals to X according to our definition. What is the value of DM? Here, DM will be equal to DE minus ME. Again, DE minus ME equals to DM. Okay? So DM equals to DE minus ME. DM equals to DE minus ME. So DM equals to DE, that is actually 12 units, minus ME, that is equal to X according to our definition. So, in conclusion, we found out that DM equals to 12 minus X. So here we write down that DM equals to 12 minus X. So we have already proved that quadrilateral ADMS is a rectangle because it has 4 right angles, and so in quadrilateral ADMS, it is a rectangle. So actually in rectangle ADMS, we note that the opposite sides are equal to each other, that is to say DM equals to AS. DM equals to AS. We'll repeat again. In rectangle ADMS, the opposite sides are equal to each other, that is to say DM equals to AS. But we just right now found out that DM equals to 12 minus X. So we can write here that DM equals to 12 minus X. And from this equation, 12 minus X equals to DM equals to AS, we will conclude that AS also equal to 12 minus X. Okay, AS equals to 12 minus X. So we can write here that AS equals to 12 minus X. Likewise, in rectangle SMPE, in rectangle SMPE, this rectangle the opposite sides are equal to each other, that is to say ME equals to SP. ME equals to SP in rectangle SMPE, this rectangle, ME equals to SP, but ME equals to X according to our definition. So we can write here that ME equals to X, And from this equation, x equals to ME equals to SP, we will derive that SP also equals to x. So we can write here that SP equals to x. In the next step, we'll find out first of all, we will define MO as y. Again, MO equals to y according to our definition. Here, MO equals to y according to our definition. So, what is the value of SO? SO SO will be equal to MO minus SM. MO minus SM will be equal to SO. Again, here, MO minus SM equals to SO. So SO equals to MO, but MO equals to Y according to our definition, minus SM, and SM equals to 4. We've already found out that SM equals to 4. So in conclusion, we found out that SO equals to Y minus 4. So we can write here that SO equals to Y minus 4. And what is the value of AO? The value of AO, the value of line segment AO is A is the center of this circle that its radius is 4. O is the center of the biggest circle that its radius equals to R according to our definition. And the biggest circle and this circle have an internal notch between them at this point. They are touching each other at this point. Whenever you have an internal notch between two circles, then the distance between their centers will be equal to the difference between the lengths of their radiuses. So the radius of the big circle is capital R. The radius of the small circle is 4, so the difference between the radiuses is capital R minus 4. So AO equals to R minus 4. So in the next step, we will implement the Pythagoras theorem on the right triangle OAS. I'll repeat again. We will implement the Pythagoras theorem on the right triangle OAS. So I will copy triangle AOS in a new page, and I will implement the Pythagoras theorem on the triangle. This is a right triangle, of course. So here, I'll get AOS. So this green triangle is the right triangle, triangle AOS, and we will implement the Pythagoras theorem on this green right triangle, triangle AOS. So here, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AO. The square of the hypotenuse is AO square, and it must be equal to SO square plus AS square. So I write it down. So in the right triangle, triangle AOS, according to the Pythagoras theorem, we get that AO squared, it is the square of the hypotenuse, equals to OS squared plus AS squared. So here AO equals to R minus 4, so AO square will be equal to R minus 4 squared, and it equals to OS square. OS equals to Y minus 4, so OS square will be equal to Y minus 4 squared plus AS square. AS equals to 12 minus X, so AS square will be equal to 12 minus X squared. So here, so we got that according to equation number 1, R minus 4 squared equals to Y minus 4 squared plus 12 minus X squared. Here we will open the brackets on both sides of this equation, equation number 1, and we will get that according to equation number 1, R minus 4 squared is R squared plus 16 minus 8R, and it equals to Y minus 4 squared. Y minus 4 squared is Y squared plus 16 minus 8Y plus 12 minus X squared. 12 minus X squared is 12 squared, that is 144, plus X squared minus 24X. So here we have 16 on both sides of equation number 1, so 16 will get cancelled. We will add 8R to this equation, equation number 1, and we will get that R squared equals to 8R minus 8Y plus 144 plus, minus 24X plus x squared plus y squared. So here we will subtract x squared and y squared from this equation number 1, and we will get that r squared minus x squared minus y squared equals to 8r minus 8y plus 144 minus 24x. Here we will take a common factor out of those two expressions. So here 8 is a common factor, so inside the brackets we will have r minus y. R minus y plus 144 minus 24x equals to rx r squared minus x squared minus y squared. So we actually found out that according to equation number 1, r squared minus x r squared minus x squared minus y squared equals to 8 times r minus y plus 144 minus 24x. Okay? In the next step, from point O, we will draw perpendicular to BE. From point O, we will draw perpendicular to BE. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. We will define the touching point between the perpendicular from point O and BE as point T. We will focus on quadrilateral OTSP. This quadrilateral OTSP. Here, or actually, we will focus on quadrilateral OTEM. On quadrilateral OTME. Here, quadrilateral OTME. As three right angles, 1, 2, 3. The sum of three right angles is 270 degrees plus the plus angle MOT in total. The sum of those four angles must be equal to 360 degrees. And repeat again, the quadrilateral OTME, the sum of the angles must be equal to 360 60 degrees, that is to say 270 degrees plus the size of angle MOT must be equal to 360 degrees. We subtract 270 degrees from this equation, and we'll get that angle MOT equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle MOT is the right angle, it equals to 90 degrees. So angle MOT is the right angle. So quadrilateral MOT is 4 right angles. Therefore, quadrilateral MOT is a rectangle. I'll write it down. Quadrilateral OTME is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, ME equals to OT. ME equals to OT in rectangle OTME. ME equals to OT. But according to our definition, ME equals to X. ME equals to X according to our definition. So from this equation, X equals to ME equals to OT, we will derive that OT also equals to X. OT equals to X. OT equals to X. In the next step, we will find out the value of BT. What is the value of BT? You can see from the drawing that BT equals to BE minus ET. BT equals to BE minus ET, but here OT ME is a rectangle. Therefore, the opposite sides of a rectangle are equal to each other. That is to say, OM equals to TE. OM equals to TE in rectangle OTME. OM equals to TE in rectangle OTME. OM equals to TE. But OM equals to Y according to our definition. So we can write down that OM equals to Y. So from this equation, Y equals to OM equals to TE. We will derive that TE also equals to Y. TE or ET equals to Y. And we know that BE is the radius of this circle, that is to say it equals to 9 units. So BE equals to 9. So in conclusion, we found out that BT equals to BE, that is 9, minus TE, that is y. So BT equals to 9 minus y. BT equals to 9 minus y. And what is the value of OB? O is the center of the biggest circle, that is to say, and we know that the center of the biggest circle is equal to capital R. B is the center of this circle that its radius is 9 units, so, and the biggest circle and this circle have an internal length between them at this point. They are touching each other at this point, and whenever you have an internal length between two circles, then the distance between their centers, that is to say OB, will be equal to the difference between the lengths of their radiuses, and the difference between the lengths of the radiuses of the biggest circle and this circle is capital R minus 9. So OB equals to capital R minus 9. So here we'll focus on the right triangle OBT. We'll implement the Pythagoras theorem on the right green triangle OBT. So I will copy the right triangle in a new page, and we will implement the Pythagoras theorem in this right triangle. So here we have the MEOT, here quadrangle OTME. So this is the right triangle OBT. So we'll implement the Pythagoras theorem on the right green triangle OBT. So here the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is OB squared, and it equals to the sum of the squares of the perpendiculars. That is to say, OB squared equals to BT squared plus t all square. I will repeat again. The right triangle OBT, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OB square equals to BT square plus OT square. OB equals to R minus 9. So OB square is R minus 9 square equals to BT square. BT is 9 minus y, so BT square is 9 minus y square plus OT square. OT is x, so OT square is x square. So in conclusion, we found out that according to equation number 2, r minus 9 square equals to 9 minus y square plus x square. Here we will open the brackets on both sides of equation number 2, and we will get that r minus 9 square is equal to r square plus 81 minus 18r, and it equals to 9 minus y square. 9 minus y square is 81 plus y square minus 18y plus x square. Here in this equation number 2, we have 81 on both sides of the equation, so 81 will get cancelled. We will subtract 18 out from this equation number 2, and we will get that r square equals to 18r minus 18y plus x square plus y square. Here we subtract x square and y square from this equation number 2, and we will get that r square minus x square minus y square equals to 18r minus 18y. Here we will take 18 as a common factor out of those two expressions, and we'll get that according to equation number 2, r square minus x square minus y square equals to 18 is a common factor, so inside the brackets we will have r minus y. So in conclusion, we found out that according to equation number 2, r square minus x square minus y square equals to 18 times r minus y. So here in the next step, we will draw perpendicular from point C to BE. So this angle equals to 90 degrees, and this angle will also equal to 90 degrees. We will define the touching point of the perpendicular from point C and BE as point Q. We will join points B and C together by a straight line. What is the value of BC? B is the center of this circle that its radius is 9 units. C is the center of the smallest circle that its radius is 1 unit. Those two circles, the smallest circle and this circle, have an external launch between them. Whenever two circles have an external launch between them, then the distance between their centers, that is to say BC, will be equal to the sum of the lengths of their radii. And the radius of this circle is 9 units, the radius of this circle is 1 unit. The sum of those two numbers, 9 plus 1 is 10, so BC equals to 10 units. Quadrilateral QCEF, quadrilateral QCEF has 1, 2, 3 right angles, and the sum of 3 right angles is 270 degrees. So 270 degrees plus the size of angle QCF must be equal to 360 degrees. I'll repeat again. 270 degrees plus the size of angle QCF must be equal to 360 degrees in quadrilateral QCF, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtract 270 degrees from this equation, and we'll get that angle QCF equals to 360 degrees minus 270 degrees is 90 degrees. So this angle is a right angle, therefore quadrilateral QCEF that has 4 right angles is a rectangle. Quadrilateral QCEF is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, CF equals to QE. CF equals to QE. But CF equals to 1 unit because it is the radius of the smallest circle. Okay. CF equals to QE according to the rule that the opposite sides of a rectangle are equal to each other, and CF equals to 1 unit because it is the radius of the smallest circle. From this equation, 1 equals to CF equals to QE, we will derive that QE also equals to 1 unit. Here QE equals to 1 unit. And we will focus on the right triangle QBC. In the right triangle QBC, what is the value of QB? QB equals to BE minus QE. QB equals to QE. QB equals to BE minus QE. QB equals to BE minus QE. I repeat. QB equals to BE minus QE. That is to say, QB equals to BE equals to 9 units. This is the radius of this circle. And we just right now found out that QE equals to 1. So QB will be equal to 9 minus 1. 9 minus 1 is 8. So QB equals to 8 units. Here QB equals to 8 units. So we focus on the right triangle QBC. According to the Pythagoras theorem, in the right triangle QBC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. BC is the hypotenuse, so the square of the hypotenuse is BC squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to QC squared plus BQ squared. So I'll repeat again. In the right triangle QBC, according to the Pythagoras theorem, PT is the Pythagoras theorem, a version for Pythagoras theorem. BC square equals to QC square plus BQ square. BC is the hypotenuse. We found out that the hypotenuse equals to 10, so BC square is 10 square, 10 square is 100, equals to QC square. QC is the missing variable, so we will leave it as it is, plus BQ square. BQ equals to 8 units, so BQ square is 8 square, 8 square is 64. So in conclusion, we found out that $100 equals to QC square plus 64. Here we subtract 64 from this equation, and we get that 100 minus 64 is 36. 36 equals to QC squared. Here we'll take a root out of this equation and we'll get that QC equals to the square root of 36. The square root of 36 is 6. So we found out that QC equals to 6 units. And we have only found out that QCEF is a rectangle and the opposite sides of a rectangle are equal to each other. That is to say QC equals to EF. QC equals to EF, but QC equals to 6. Just like now found that QC equals to 6, so from this equation 6 equals to QC equals to EF, we will conclude that EF also equals to 6 units. So here EF equals to 6 units. And in the next step we will draw perpendicular from point C to OM. So this angle equals to 90 degrees and this angle also equals to 90 degrees. We define the touching point of the perpendicular from point C to OM as U. The touching point between the perpendicular from point C to OM is defined as U. Actually, here we know that quadrilateral UCFM has 4 right angles because this angle equals to 90 degrees, this angle also equals to 90 degrees, this angle equals to 90 degrees, and this angle equals to 90 degrees. So quadrilateral UCMF is a rectangle and the opposite sides of a rectangle are equal to each other. That is to say CF equals to UM, CF equals to UM, but CF equals to 1 unit. From this equation 1 equals to CF equals to UM, we will derive that UM also equals to 1 unit. So here UM equals to 1 unit, and what is the value of UO? The value of UO, the value of line segment UO equals to OM minus UM. OM minus UM equals to UO. I'll repeat again. UO equals to OM minus UM. So UO equals to OM. OM equals to Y according to our definition. And we just right now found out that UM equals to 1. So in conclusion, we found out that UO equals to Y minus 1. And here we know that quadrilateral UMQE is a rectangle. Anyway, in quadrangle UMEQ we have 1, 2, 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. So actually, quadrangle UMQE is a rectangle. Quadrangle UMQE is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, ME equals to QU. ME equals to QU. According to the rule that the opposite sides are equal to each other, ME of a rectangle are equal to each other, ME equals to QU. But ME equals to X according to our definition. From this equation, X equals to M equals to QU, we derive that QU also equals to X. So here QU equals to X. Here we will join points O and C together by a straight line. So what is the length of OC? The length of OC, O is the center of the biggest circle, C is the center of the smallest circle, and the smallest circle and the biggest circle have an internal length between them at this point. They are touching each other at this point, therefore the distance between their centers, that is to say OC, will be equal to the difference between the lengths of their radiuses. The radius of the biggest circle is capital R, the radius of the smallest circle is 1, so the difference is capital R minus 1. That is to say OC equals to capital R minus 1 or R minus 1. OC equals to R minus 1. Okay. And UC equals to X plus 6. So in the next step, we will focus on the right triangle OUC. We will focus on the right triangle OUC, and we will implement the Pythagoras theorem on the right triangle OUC. So I will copy the right triangle OUC in a new page, and we will implement the Pythagoras theorem on this right triangle OUC. Okay. So this is the right triangle OUC. We will implement the Pythagoras theorem on this right triangle. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to OU square plus UC square. I'll write it down. OC square is the square of the hypotenuse. That equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to OU square plus UC square so here OC equals to R minus 1, so R OC square is R minus 1 square. That equals to OU square. OU is Y minus 1, so OU square is Y minus 1 square plus UC square. UC equals to X plus 6, so UC square will be equal to X plus 6 square. So in conclusion, we found out that according to equation number 2, R minus 1 square equals to Y minus 1 square plus X plus 6 square. We'll open the brackets on both sides of this equation, equation number 3, and we'll get that R minus 1 square is R square plus 1 minus 2R. That equals to Y minus 1 square. Y minus 1 square is Y square plus 1 minus 2Y plus X plus 6 square is X square plus 36 plus 12X. So here we have 1 on both sides of equation number 3, so 1 will get cancelled. We will add 2R to this equation, equation number 3, and we will get that according to equation number 3, R square equals to 2R minus 2Y plus 36 plus 12X plus X square plus Y square. Here we subtract X square and Y square from this equation, equation number 3, and we will get that R square minus X square minus Y square equals to 2R minus 2Y plus 36 plus 12X here we'll take 2 as a common factor of those two expressions, and we'll get that according to equation number 3, R square minus X square minus Y square equals to 2 times R. 2 is a common factor, so inside the brackets we will have R minus Y plus 36 plus 12X. Okay, so I will copy equation number 3 in a new page, and we will copy in one page all 3 equations, and we will solve the 3 equations in order to find out the value of the biggest circle, the radius of the biggest circle, that is actually capital R, equals to capital R. So the third equation is r squared minus x squared minus y squared equals to 2 times r minus y plus 36 plus 12x. So this is equation number 3. Equation number 2 is r squared minus x squared minus y squared equals to 18 times r minus y, and the equation number 1 is r squared minus x squared minus y squared equals to 8 times r minus y plus 144 minus 24x. So here we will compare equation number 1 to equation number 2, and in this way we'll create equation number 4. Again, equation number 4 states that r squared minus x squared minus y squared, according to equation number 1, must be equal to r squared minus x squared minus y squared, according to equation number 2. R squared minus x squared minus y squared, according to equation number 1, is 8 times r minus y plus 144 minus 24x, and it must be equal to r squared minus x squared minus y squared, according to equation number 2, that is actually equals to 18 times r minus y. Here we subtract 8 times r minus y from this equation, equation number 4, and we'll get that according to equation number 4, 144 minus 24x equals to 10 times r minus y. Here we'll divide this equation, equation number 4, by 10, and we'll get that r minus y equals to 144 minus 24x over 10. Here we will divide both the numerator and the denominator of this side of equation number 4 by 2, and we will get that according to equation number 4, r minus y equals to 144 over 2 is 72, minus 24x over 2 is minus 12x, 10 over 2 is 5. So in conclusion, we found out that according to equation number 4, r minus y equals to 72 minus 12x over 5. Likewise, we will compare equation number 2 to equation number 3. And in this way, we'll create equation number 5 that states that rx minus x squared, r squared minus x squared minus y squared, according to equation number 2, must be equal to r squared minus x squared minus y squared, according to equation number 3. So r squared minus x squared minus y squared, according to equation number 2, is 18 times r minus y, and it must be equal to r squared minus x squared minus y squared, according to equation number 3, that is actually equals to 2 times r minus y plus 36 plus 12x. So here we will subtract 2 times r minus 5 from this equation, equation number 5, and we will get that 16 times r minus y equals to 36 plus 12x. Here we will divide the equation number 5 by 16, and we will get that according to equation number 5, r minus y equals to 36 plus 12x over 16. Here we will divide both the numerator and the denominator of this side of equation number 5 by 4, and we will get that according to equation number 5, r minus y equals to 36 over 4 is 9, 12x over 4 is 3x, 16 over 4 is 4. So in conclusion, we found out that according to equation number 5, r minus y equals to 9 plus 3x over 4. But according to equation number 4, r minus y equals to 72 minus 12x over 5. In the next step, we will create equation number 6 that states that r minus y according to equation number 4 must be equal to r minus y according to equation number 5. So r minus y according to equation number 4 is 72 minus 12x over 5, and it must be equal to r minus y according to equation number 5, that is actually 9 plus 3x over 4. Here we will cross multiply equation number 6, and we will get that according to equation number 6, 4 times 72 minus 12x equals to 5 times 9 plus 3x. Here we will open the brackets on both sides of this equation number 6, and we will get that according to equation number 6, 4 times 72 is 188, minus 4 times 12x is minus 48x, equals to 5 times 9 is 45, 5 times 3x is 15x. We will subtract 45 from this equation number 6. 188 minus 45 is 143. And 143 equals to 15x plus 48x is 63x. Here we will divide this equation number 6 by 9, and we will get that 243 over 9 is 27. According to equation number 6, 27 equals to 63 over 9 is 7x. So here we'll divide this equation by 7, and we will get that x equals to 27 over 7 according to equation number 6. Okay, we found out the value of x, it equals to 27 over 7. So now we can put the value of x inside equation number 5. We will do it now. According to equation number 5, r minus y equals to 9 plus 3x over 4, and we know that x equals to 27 over 7. So we will put the value of x inside equation number 4. We'll substitute x by 27 over 7 in equation number 5. And we will get that according to equation number 5, r minus y equals to 9 plus 3x, and x equals to 27 over 7. So we'll substitute x by 27 over 7, all divided by 4. Okay, so according to equation number 5, r minus y equals to 9 plus 3 times 27 is 81 over 7 over 4. Here we will multiply 9 by 7 and we will divide it by 7 in order to have a common factor with 81 over 7. And we will get that according to equation number 5, r minus y equals to 9 times 7 is 63 plus 81 over 7 over 4. We'll move 4 to the denominator here, and 4 times 7 is 28. So in conclusion, we found out that according to equation number 5, r minus y equals to 63 plus 81 is 144, and the denominator we have 28. 144 over 4 is 36, 28 over 4 is 7. So in conclusion, we found out that according to equation number 5, r minus y equals to 36 over 7, while according to equation number 6, we found out that x equals to 27 over 7. We have equation number 2 that states according to equation number 2, rx minus r squared minus y squared minus x squared equals to 18 times r minus y. I'll repeat again. According to equation number 2, we found out that r squared minus y squared minus x squared equals to 18 times r minus y. So here we will substitute r minus y by 36 over 7, and we know that r squared minus y squared equals to r plus y times r minus y. According to the algebraic identity that a squared minus b squared equals to a plus b times a minus b. So it equals to 18 times r minus y, and r minus y equals to 36 over 7. So here we got that r plus y times r minus y, and r minus y is 36 over 7. And it equals to 18 times 36 over 7 plus x squared plus, but x squared equals to 27 over 7, so we substitute x squared by 27 over 7 squared. So here we will divide this equation by 7, and we will actually multiply this equation by 7, and we will get that according to equation number 2, r plus y times 36 equals to 18 times 36 plus 27 times 27 over 7. Here we will divide this equation by 9, and we will get that according to equation number 2, (36 over 4 is 9, so 36 over 9, we divided this equation by 9. 36 over 9 is 4, so 4 times r plus y equals to 18 over 9 is 2. 2 times 36 is 70, 2 times 36 is 72, plus 27 over 9 is 3, so it is 3 times 27 over 7. Here we will multiply 72 by 7, and then we will divide it by 7 in order to have a common factor with this expression. 3 times 27 is 81, plus 72 times 7 over 7, that equals to 4 times r plus y. So here 72 times 7 is 504, plus 81 over 7 equals to 4 times r plus y. 504 plus 81 is 585 over 7 equals to 4 times r plus y. Here we divide this equation number 2 by 4, and we get that according to equation number 2, so we will divide the equation number 2 by 4, and we will get that r plus y equals to 585 over 7 times 4 is 28. So we found out that r plus y equals to 585 over 28. But according to equation number 5, we have already found out that r minus y equals to 36 over 7. Here we'll multiply 36 over 7, both the numerator and the denominator by 4. So 36 times 4 is 144, and 7 times 4 is 28. So according to equation number 2, r plus y equals to 585 over 28. And according to equation number 5, we have already found out that r minus y equals to 144 over 28. We will add equation number 2 to equation number 5, and we will get that r plus r is 2r, y plus minus y is 0, so 2r equals to 585 plus 144 over 28. 144 plus 585 is 729 over 28 equals to 2r. Here we will divide this equation by 2 and we'll get that r equals to 729 over 56 units, or in terms of numbers it equals to 13.018 units. Okay, so we found out that the radius of the biggest circle is equal to either 729 over 56 units, or we can represent it also as 13.018 units. That is the answer to the question. In the next step, I will summarize the lecture. Again, the radius of the biggest circle equals to either 729 over 56 or 13.018 units. So in the next step, I will summarize the lecture. Actually, we wanted to find out the radius of the biggest circle here. We have here four circles. The three circles are located inside the biggest circle. The radius of this circle is 4 units, the radius of this circle is 9 units, and the radius of the smallest circle is equal to 1 unit. And we want to find out the radius of the biggest circle. We define the center of this circle as point A, we define the center of this circle as point B, when we defined the center of the smallest circle as point C. We defined the touching point, or the point of tangency of the straight line with this circle as point D. We defined the point of tangency of the straight line with this circle as point A, and we defined the point of tangency of the straight line with the smallest circle as point F. Then we join together points A and D, or points B and E, and points C and F. All those line segments are defined as the radiuses of those circles. AD is the radius of this circle. Why? Because line segment AD starts from the center of this circle, that is to say from point A, and ends at point D, that is a point on this circle itself. Therefore, line segment AD is the radius of this circle. Likewise, for the same reason, BE is the radius of this circle, and CF is the radius of the smallest circle. Then, actually, two circles can touch each other in two different ways. The first way is the internal lunge. In this way, or this type of touching between the two circles is defined as internal lunge. Why? Because the small circle is inside the big circle, and they are touching each other internally at point S. Point S is the touching point or the point of tangency between the small circle and the big circle. What is the distance between the centers of those two circles? OM, again, M is the center of the small circle, O is the center of the big circle. OM is the distance between the centers. Small r is the radius of the small circle, capital R is the radius of the big circle. So the distance between the centers of those two circles, that is OM. OM, you can see it easily from the drawing, that OM equals to OS minus SM. OS is capital R, SM is small r, therefore OM equals to capital R minus small r. Okay, so whenever you have an internal lunge between two circles, that is to say they are touching each other internally, then the distance between their centers will be equal to the difference between the lengths of their radiuses. And the length of the radius of the big circle is capital R, the length of the radius of the small circle is small r, and the difference between the lengths is capital R minus small r. This is the first type of tangency between two circles, that is the internal lunge. The second type of tangency between two circles is defined as the external lunge. When the two circles touching each other externally, no circle is inside the other circle. They are touching each other externally at point S. Point S is the touching point. So this type of tangency between the two circles is defined as external point. And whenever you have an external point, then the distance between the centers of the two circles, that is to say OM or MO, equals to the sum of the lengths of the radiuses, that is to say it equals to R, capital R plus small r. So OM equals to OS plus MS equals to R plus R, or OM equals to capital R plus small r. Okay? And S is the point of tangency, they are touching each other at point S. So this is the second type of tangency between two circles, the external lunge and the distance between the centers of the two circles is equal to the sum of the length of the radiuses, that is to say it is capital R plus small r. Okay? So, the next step we solve the question. So here we have we actually from point A we draw perpendicular to BE, but before that I presented to you a new rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. Again, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. What is the meaning of rule number 1? The meaning of rule number 1 is that here we have the radius AD of this circle. It is drawn to the point of tangency, that is to say it is drawn to point D, that is the point of tangency of the point of tangency of the straight line with the circle. And because of the fact that the radius AD is drawn to the point of tangency, then the tangent here, that is the straight line, will be perpendicular to this radius AD. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we have here the radius BE that is drawn to the point of tangency. That is to say, it is drawn to point E, that is the point of tangency of the straight line with this circle. Therefore, in this case, whenever you have a radius that is drawn to the point of tangency, then the tangent will be perpendicular to the radius. Here, the tangent, the straight line, will be perpendicular to the radius BE. That is to say, this angle will be equal to 90 degrees, and this angle will be equal to 90 degrees. I will not repeat on the same process here. This angle will be equal to 90 degrees, and this angle will be equal to 90 degrees for the same reason that the radius CF is drawn to the point of tendency. Therefore, the straight line will be perpendicular, that is the tangent will be perpendicular to the radius CF, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Okay? In the next step, we move perpendicular from point A to BE. So, here, this angle equals to 90 degrees, this angle also equals to 90 degrees. We define the touching point between the perpendicular from point A to BE as point P. Okay? So, here, quadrilateral SMEF has 3 right angles. Here, quadrilateral, it is actually quadrilateral APDE. This quadrilateral has 3 right angles, 1, 2, 3. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the 4th angle, that is actually angle DAP. In total, the sum of those 4 angles, they must be equal in total to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we will subtract 270 degrees from this equation, and we will get that angle DAP equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that this angle is a right angle, it equals to 90 degrees. Therefore, because of the fact that the quadrilateral ADPE has 4 right angles, it must be a rectangle. Quadrilateral APDE is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, AD equals to PE. Okay, AD equals to PE, but AD equals to 4 units because it is the radius of this circle. From this equation, 4 equals to AD equals to PE, we will conclude that PE also equals to 4 units. So we can write here that PE equals to 4 units. And what is the value of BP? You can see it easily from the drawing that BP equals to BE minus PE. Okay, BP equals to BE minus PE. That is to say, BP equals to BE, that is 9 units, EP, that is 4 units. 9 minus 4 is 5, so we found out that BP equals to 5 units. These 9 segments, BP equals to 5 units. Then we focus on quadrilateral ASDM. In quadrilateral ASDM, this quadrilateral, we have 1, 2, 3 right angles here, this quadrilateral ASDM, we have 1, 2, 3 right angles. We found out that this angle equals to 90 degrees, so we have here 3 right angles, and the sum of 3 right angles is 270 degrees plus the size of angle ASM plus the size of this angle. In total, the sum of all those 4 angles it must be equal in total to 360 degrees. So here we subtracted 270 degrees from this equation, and we got that angle ASM equals to 360 degrees minus 270 degrees is 90 degrees. So angle ASM, this angle is a right angle, it equals to 90 degrees. And because of the fact that quadrilateral ASDM has 4 right angles, it must be a rectangle. Okay, so quadrilateral ASDM is a rectangle, and here we, from point O, we draw perpendicular to DE, and we define the tangent point between the perpendicular from point O to DE as M. So this angle equals to 90 degrees and this angle equals to 90 degrees. Okay? And that is the reason that in quadrilateral ASDM we have 3 right angles, 1, 2, 3. And because of the fact the 4th angle must be also equal to 90 degrees, so this angle equals to 90 degrees. Okay, this angle equals to 90 degrees. Whenever you have 3 angles inside a quadrilateral that are right angles, then the 4th angle must be also equal to 90 degrees, so this angle must be also equal to 90 degrees. And here we have, from point O we draw perpendicular to DE, so OM as a perpendicular, it must be a straight line. OM is a straight line, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line OM at point S, then the sum of the angles here must be equal to 180 degrees. So here 90 degrees plus angle SAO must be equal to 180 degrees. 90 degrees plus angle ASO equals to 90 degrees. Here 280 degrees. Here we subtract the 90 degrees from this equation, and we got that angle OSA equals to 90 degrees. So this angle is equal to 90 degrees. Okay. And so therefore triangle AOS will be a right triangle. Then quadrilateral SMEP, this quadrilateral in the green color has 3 right angles, 1, 2, 3. So it has 3 right angles, and because of the fact that it has 3 right angles, I will not repeat on the same process. The 4th angle must be also equal to 90 degrees. Here you can see quadrilateral. Okay, I'll repeat on it. 270 degrees plus angle MSP must be equal to 360 degrees in quadrilateral SMEP. So we subtracted 270 degrees from this equation, and we found out that angle MSP equals to 90 degrees. Angle MSP, this angle equals to 90 degrees. Therefore, quadrilateral SPME is a rectangle. Quadrilateral SPME is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, SP SM equals to PE, SM equals to PE in quadrangle SPEM, but we have already found out that PE equals to 4 units. From this equation, SM equals to PE equals to 4, we derive that SM also equals to 4. SM also equals to 4. Then we join together points A and B by a straight line. What is the value of AB? Point A is the center of the radius that is of the circle that its radius is 4 units. Point B is the center of the radius of the circle that its radius is equal to 9 units. And here, those two circles have an external notch between them. That is to say, they are touching each other externally at this point. Whenever you have two circles with an external notch between them, then the distance between their centers will be equal to the sum of the lengths of their radiuses. That is to say, it will be equal to the radius of this circle that is 4 plus the radius of this circle that is 9. 4 plus 9 is 13. So we found out that AB equals to 13 units. We have already found out that BP equals to 5 units. And the missing variable is AP in the right triangle ABP. So we focused on the right triangle ABP according to the Pythagoras theorem. On the right triangle ABP, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to BP square plus AP square. AB equals to 13. AB equals to 13, so AB square is 13 square. 13 square is 169. BP equals to 5. BP square is 5 square. 5 square is 25 plus AP square. So in conclusion, we got that 169 plus 25, 169 equals to 25 plus AP square. We subtracted 25 from this equation, and 169 minus 25 is 144. So in conclusion, we found out that 144 equals to AP square. Here we took a root out of this equation, and we found out that AP equals to the square root of 144. The square root of 144 is 12, so we found out that AP equals to 12 units. Here AP equals to 12 units, and we know that quadrangle APDE, we have already proved that quadrangle APDE is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, AB equals to DE. AP equals to DE, according to the rule that the opposite sides in a rectangle are equal to each other. But we just right now found out that AP equals to 12. So from this equation, 12 equals to AP equals to DE. We will derive that DE also equals to 12 units. Here, DE equals to 12 units. So here, we focused on the right triangle, triangle AOS. What is the value of OS? Here, OS, you can see here that OS or SO equals to MO minus SM. Okay, again, SO equals to MO minus SM. SO equals to MO minus SM. Actually, MO is equal to Y according to our definition. SM equals to 4. So in conclusion, we found out that SO equals to Y minus 4. SO equals to Y minus 4. And here we have rectangle ADMS. In rectangle ADMS, the opposite sides are equal to each other. And so here actually we defined ME as x, therefore DM will be equal to 12 minus x, and we know that the opposite sides of rectangle AS DM are equal to each other, so if DM equals to 12 minus x, then AS will be also equal to 12 minus x, and here, because of the fact that ME equals to x, then ASP will be also equal to x, because the opposite sides in rectangle ASEP are equal to each other, so if ME equals to x, then ASP will be also equal to x. And here also AS equals to 12 minus x, like DM. So we focus on the right triangle AOS. We know that AES equals to 12 minus x, OS equals to y minus 4, and what is the value of AO? A is the center of the radius that is the center of the circle that its radius is 4 units. O is the center of the biggest circle that its radius equals to capital R. The biggest circle and this circle have an internal notch between them at this point. Therefore, the distance between their centers will be equal to the difference between the lengths of their radiuses, that is to say, it will be equal to capital R minus 4. So AO equals to capital R minus 4. So we focused on the right triangle AOS, and we implemented the Pythagoras theorem on the right triangle AOS, the right green triangle AOS. So I copied triangle AOS, the right triangle AOS, in this new page, and we implemented the Pythagoras theorem on the right triangle AOS. Here, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, AO square, that is the square of the hypotenuse, must be equal to OS square plus AS square. AO square equals to SO square plus AS square. AO equals to R minus 4, so AO square is R minus 4 square. OS equals to Y minus 4, so OS square will be equal to Y minus 4 square. AS equals to 12 minus X, so AS square will be equal to 12 minus X square. We open the brackets on both sides of this equation number 1, and we got that R minus 4 square is equal to R square plus 16 minus 8R, and it equals to Y minus 4 square. Y minus 4 square is Y square plus 16 minus 8Y, and 12 minus X square is 144 plus X square minus 24X. Here we have 16 on both sides of the equation, so 16 will get cancelled. And we added 8R to this equation, and we got that R square equals to 8R minus 8Y plus 144 minus 24X plus X square plus Y square. Here we subtracted X square and Y square from this equation, and we got that R square minus X square minus Y square equals to 8R minus 8Y plus 144 minus 24X. Here we took a common factor 8 out of those two expressions. So we got here, after we took from those two expressions 8 as a common factor inside the brackets, we left with R minus Y. So in conclusion, we got that according to equation number 1, R square minus X square minus Y square equals to 8 times R minus Y plus 144 minus 24X. Okay, then actually, from point O, we draw perpendicular to BE. So this angle equals to 90 degrees and this angle equals to 90 degrees. We define the touching point between the perpendicular from point O to BE is point T. And we focus on the right triangle OBT. Here, what is the value of BT? The value of BT equals to BE minus TE. Okay, BT equals to BE minus TE, and BE equals to 9 units, and TE, what is the value of TE? The value of TE equals to OM. Why? Because quadrilateral OTEM is a rectangle and the opposite sides of a rectangle are equal to each other. So TE equals to OM. Okay? TE equals to OM. But but OM equals to Y. OM equals to Y, so TE will be also equal to Y, okay? According to our definition, OM equals to Y, and TE equals to OM. TE equals to OM, therefore TE will be also equal to Y. Okay, so BT equals to BE minus TE, that is to say it equals to 9 minus Y. So BT equals to 9 minus Y. And here we know that in quadrilateral OTME, we have 1, 2, 3 right angles. So 270 degrees plus the size of angle MOT, the size of this angle. In total, the sum of those 4 angles must be equal to 360 degrees. We subtracted 270 degrees from this equation, and we got that the size of angle MOT equal to 90 degrees. Therefore, quadrilateral OBTE is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, ME equals to OT, but ME equals to X according to our definition. So from this equation, we will derive that OT also equals to X. OT also equals to X. And here I already proved that BT equals to 9 minus Y. So I draw triangle BOT in this new page, and we implemented the Pythagoras theorem in this triangle BOT. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BO square will be equal to BT square plus TO square. Okay? BO square equals to BT square plus TO square. BO equals to R minus 9, so BO square is R minus 9 square. BT equals to 9 minus Y, so BT square is 9 minus Y square. OT equals to X, so OT square is X square. So in conclusion, we found out that R minus Y square equals to 9 minus Y square plus X square. So here we open the brackets on both sides of this equation number 2, and we got that R minus 9 square equals to R square plus 81 minus 18R. 9 minus Y square equals to 81 plus Y square minus 18Y plus X square. Here we have 81 on both sides of equation number 2, so 81 will get cancelled. And here we added 18R to this equation number 2, and we got that R square equals to 18R minus 18Y plus X square plus Y square. Here we subtracted X square and Y square from this equation, so we got that R square minus X square minus Y square equals to 18R minus 18Y. Here we took a common factor, 18 out of those two expressions, and we found out that according to equation number 2, R square minus X square minus Y square equals to 18 times R minus Y. So in quadrilateral QCEF, here from point C we drew perpendicular to BE. Again, from point C we drew perpendicular to BE. So this angle equals to 90 degrees and this angle also equals to 90 degrees. So in quadrilateral QCEF we have 1, 2, 3 right angles. Again, in quadrilateral QCEF we have 3 right angles. The sum of 3 right angles is 270 degrees plus the size of angle QCE plus the size of this angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation, and we count that angle QCE equals to 360 degrees minus 270 degrees equals to 90 degrees. Therefore, quadrilateral QCEF is a rectangle, this quadrilateral is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, CF equals to QE, CF equals to QE, but CF equals to 1 unit. It is the radius of the smallest circle. From this equation, 1 equals to CF equals to QE. We will derive that QE also equals to 1 unit. Here QE equals to 1 unit. Okay? And then from point C, we join points B and C together by a straight line. What is the value of BC? B is the center of the circle that its radius is 9 units. C is the center of the smallest circle that its radius is 1 unit. And we have an external length between those two circles. Whenever we have an external length between the two circles, then the distance between their centers, that is to say BC, will be equal to the sum of the lengths of their radiuses. That is to say, it will be equal to 9 plus 1. 9 plus 1 is 10, so BC, the length of BC is 10. And here, what is the value of BQ? BQ equals to BE minus QE. Okay? BQ, QB equals to BE minus QE, but BE is the radius of this circle that equals to 9 units. QE, we just right now found out that QE equals to 1 unit. So QB equals to 9 minus 1. 9 minus 1 is 8. So here QB equals to 8 units. We already found out that BC equals to 10 units, so we focused on the right triangle, triangle QBC. According to the Pythagoras theorem, triangle QBC is a right triangle because of the fact that angle BQC equals to 90 degrees. So, according to the Pythagoras theorem, in the right triangle, triangle QBC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is BC, so this is BC square. It must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to QC square plus BQ square. BC equals to 10, so BC square is 10 square. 10 square is 100. QC is the missing variable, so QC square is QC square. BQ, we just right now found out that BQ equals to 8 units, therefore BQ square will be equal to 8 square. 8 square is 64. So we have the equation that 100 equals to QC square plus 64. We subtracted 64 from this equation, and we got that 100 minus 64 is 36, so 36 equals to QC square. We took a root out of this equation, and we found out that QC equals to the square root of 36. The square root of 36 is 6. So we found out that QC equals to 6 units, but because of the fact that quadrilateral QCEF is a rectangle and the opposite sides of a rectangle are equal to each other, we will get that QC equals to EF. QC equals to EF, but we just right now found out that QC equals to 6 units. So from this equation 6 equals to QC equals to EF, we will derive that EF also equals to 6 units. Then actually here from point C we draw perpendicular to OM. In quadrilateral UMCF we have 1, 2, 3, 4 right angles, therefore quadrilateral UCMF is a rectangle. Quadrilateral UCMF is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, CF equals to UM, but CF equals to 1 unit, therefore UM will be also equal to 1 unit. And okay, here CF equals to UM. According to the rule that the opposite sides in a rectangle are equal to each other, but CF equals to 1 unit, it is the radius of the smallest circle. From this equation we will derive that UM also equals to 1 unit. Here UM equals to 1 unit. And what is the value of UO? The value of UO equals to OM minus UM. Okay? UO equals to OM minus UM, but OM equals to Y according to our definition, and we just right now found out that UM equals to 1, therefore we found out that OU equals to Y minus 1, here OU equals to Y minus 1, and triangle UMQE is a rectangle because of the fact that it has 4 right angles, and therefore the opposite sides of a rectangle are equal to each other. That is to say, anyway, in quadrilateral UMQE has here 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees, therefore quadrilateral UMQE is a rectangle, okay? And because of the fact that the opposite sides of a rectangle are equal to each other, we will get that ME equals to UQ, ME equals to UQ, ME equals to UQ, but ME equals to X according to our definition. So from this equation X equals to ME equals to UQ, we will get that UQ also equals to X. UQ also equals to X. Here UQ equals to X. And then we found out the value of OC. What is the value of OC? We connected together points C and O together. We connected points O and C together by a straight line. So here OC, O is the center of the biggest circle, that its radius is capital R. C is the radius of the center of the smallest circle, that its radius is 1 unit. So OC and the smallest circle and the biggest circle have an internal notch between them at this point, therefore the distance between their centers will be equal to the difference between the lengths of their radiuses, that is to say it will be equal to capital R minus 1. So in conclusion we found out that OC equals to R, capital R minus 1, and UC, here what is the value of UC? We know that quadrilateral UMCF is a rectangle and the opposite sides of a rectangle are equal to each other, that is to say MF equals to UC. MF equals to UC, but mf equals to x plus 6, so uc will be also equal to x plus 6. So uc equals to x plus 6. So here I draw triangle OUC, the green triangle in new page, and we implemented the Pythagoras theorem in this triangle OUC. We found out that OC equals to R minus 1. Here we found out also that OU equals to Y minus 1 and UC equals to X plus 6. So here, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC squared equals to UC squared plus UO squared. And then we developed this equation, we opened the brackets, and we found out that according to equation number 3, r squared minus x squared minus y squared equals to 2 times r minus y plus 36 plus 12x. Then we wrote down all the three expressions, all three equations in this page. This is equation number 2, this is equation number 3, this is equation number 2, and this is equation number 1. And then we created equation number 4 that states that rx minus x squared minus y squared according to equation number 1 must be equal to r squared minus x squared minus y squared according to equation number 2. And for equation number 4, we got that r minus y equals to 72 minus 12x over 5. Then we created equation number 5 from equation number 2 and equation number 3. Equation number 5 states that r squared minus x squared minus y squared according to equation number 2 must be equal to r squared minus x squared minus y squared according to equation number 3. Okay, and from equation number 5 that we created from equation number 2 and equation number 3, we found out that r minus y equals to 9 plus 3x over 4, while according to equation number 5, r minus y equals to 36 plus 12x over 16, while according to equation number 4, we already found out that r minus y equals to 72 minus 12x over 5. Then we created equation number 6 that states that r minus y according to equation number 4 must be equal to r minus y according to equation number 5. Okay? So this is equation number 6. We solved equation number 6. And we found out that according to equation number 6, x equals to 27 over 7. According to equation number 5, we found out that r minus y equals to 9 plus 3x over 4. We put the value of x inside equation number 5. And we found out that according to equation number 5, r minus y equals to 36 over 7. So in conclusion, we found out that according to equation number 5, r minus y equals to 36 over 7, while according to equation number 4, x equals to 27 over 7. Then, according to equation number 2, rx minus y squared, r squared minus y squared minus x squared equals to 81. And from equation number 2, we found out that 4 times r plus y equals to 585 over 7. So we actually found out that according to equation number 2, r plus y equals to 585 over 28, while according to equation number 5, we already found out that r minus y equals to 36 over 7. So we added equation number 2 to equation number 5. So here r plus r is 2r, y minus y is 0. So in conclusion, we got that 2r equals to 729 over 28. We divided this equation by 2 and found out that the radius of the biggest circle equals to either 729 over 56, or we can present it as that the radius of the biggest circle equals to 13.018 units. Okay, thank you very much.